We're going to be dividing polynomials using synthetic division, but to get us there, let's first do a problem using long division. So here's the problem. It's going to be x cubed minus 2x squared minus 4, and we're going to divide that by x plus 1. So let me refresh your memory on how we're going to do long division. Our divisor is x plus 1. Our dividend is x cubed minus 2x squared. We're missing the first degree term, so we need to make sure we put in a placeholder plus 0x minus 4. And then we do our long division. So it's what do we need to multiply by x to get an x cubed? And the answer is x squared. And unlike arithmetic, when you're doing long division, where you put the x squared doesn't really matter. You can put it here, you can put it here. Different books do it different ways. I like to put the x squared right here over the term with the x squared in it. But then we multiply this monomial by this divisor. So x squared times x plus 1 is x cubed plus x squared. And then remember we subtract. The x cubed minus x cubed is 0. Negative 2x squared minus x squared is negative 3x squared. We bring down our 0x and we repeat the process. So x, we look at the x, figure out what we have to multiply by x to get negative 3x squared. That's negative 3x, so we have a negative 3x here. Multiply negative 3x by x plus 1. We have negative 3x squared minus 3x, and again we subtract. So 0 minus negative 3x is 3x, so we bring down our negative 4. And one more time, we're going to do division. We need to figure out what we multiply by x to get a 3x. That's a positive 3. So 3 times x plus 1 gives us 3x plus 3. And we subtract. And we have a negative 7 as our remainder. Remember, you have a couple different ways to present the answer from a long division problem. One way is we could write the result as x cubed minus 2x squared minus 4 equals the product of these two, the product of the quotient and the divisor, with the remainder added in, so plus negative 7 or just minus 7. So that's one way to present your results. Let me just remind you about the other way. We could write it as x cubed minus 2x squared minus 4 over x plus 1 equals this quotient, which is x squared minus 3x plus 3, and add the remainder over the divisor. Right? And we have this as our result. Either way is fine. It just depends on what you're going to use this for. So let me erase that so I have space for what I'm trying to get to, because I want to get to synthetic division. Synthetic division is a way in which we can do a division like this in a shorter fashion. And when I say a division like this, I mean a division where the divisor is first degree and the leading coefficient is 1. So a first degree polynomial in the denominator, leading coefficient 1. So if we do that, we can eliminate a lot of the duplication that you see here. You might not notice, but let me point it out. We have a negative 3 here. It's the same as this negative 3 and this negative 3. We have a 3 here, a positive 3 here, and a positive 3 here. And that happens all the time when you're doing long division. But synthetic division will eliminate all that duplication. Also, we have an x cubed column, we have an x squared column. We've written x squared a lot of times. We've written x a bunch of times. Synthetic division eliminates a lot of that extra writing. So here's how it works. I'm going to come over, we're going to do the same problem again. For the denominator, that divisor, I'm going to put the number that would make it equal to 0 in a box right here. So I would put -1 right there. It's the number that would make the denominator 0. Next to it, I write all of the coefficients of the dividend. That's this polynomial. So the coefficients are 1, -2, and just as we had a placeholder here, we need a 0 as well when you were using synthetic division, and -4. I'm going to leave a little space and then draw a line. We bring down our first number, and I'm dropping it down below the line. And now here's our process. Multiply these two numbers together and write it down. So -1 times 1 is -1. And then we add. And then we repeat that process. -1 times -3 is 3. And add. -1 times 3 is -3. And add. And notice what we have. The remainder is right here. And the coefficients of the quotient are right here. Compare to this quotient. So these are the coefficients of the quotient, so you could interpret that as x squared minus 3x plus 3. And present your answer much like we did over here. But let's do another problem. Let's do this problem. Well, let me erase first. And this time we'll go straight to synthetic division. So we're going to have 4x cubed minus 11x plus 5. And we're going to divide it by x minus 3. It doesn't matter if I write the division problem as a fraction or write it horizontally this way. We can still do our synthetic division. So our divisor is right here. So our 3 goes into the box. Remember, it's the opposite of this number right here, or the number that makes that polynomial equal to 0. Remember, the requirement is that it be first degree and the coefficient is 1. Now I write the coefficients of my dividend. They are 4. Notice there's no x squared term, so I need a 0, -11, and 5. And I draw my line. Bring down that first number, and now I can proceed with the process. So it's multiply these together, write it down, and add. Multiply, write it down right here, and add. Multiply, and add. So our remainder is 80, and these are the coefficients of the quotient. So we could write it this way. The results could be written this way. 4x cubed minus 11x plus 5 equals x minus 3 times our quotient. So we're interpreting this as these are the coefficients of our quotient. This is always 1 degree smaller than the degree of your polynomial that was your dividend. So this was third degree, so this will be second degree. So it is 4x squared plus 12x plus 25. There's the product, but we need to remember to add in the remainder. And we've done this synthetic division. We're going to do one last problem. I should have written this on the board earlier. Synthetic division. I'll get it up here for the last example. So here's the problem. We're going to divide x cubed plus x squared plus 8x plus 20 by x plus 2. So the opposite of this number is in our box. And our coefficients of our dividend go right here, 1, 1, 8, and 20. Draw our line. And let me just make a comment here. When you watch other videos and look at different books, where people put the boxes can vary, but the process is the same. Some people put a box here and not around the -2. But you will see some people do it this way as well. So we bring down our first number, the coefficient, first coefficient. And now we multiply and add. Multiply and add. And multiply and add. And notice this time we have a remainder of 0. And our results would look like this. X cubed plus x squared plus 8x plus 20 equals x plus 2 times our quotient. And again, these are our coefficients of our quotient. So it's x squared minus x plus 10 with a remainder of 0, which means this polynomial was actually factorable. And that will be significant in later sections.